Hello people, welcome back to my channel. So hope you are enjoying this Python skill series. So far we have covered the basics of what the Python programming language is about. So we have seen many different types of data structures like tuples, list, set, dictionary, and we also saw some of the operations and the syntax and semantics what is followed in this. And I also mentioned about where few of these will be used in the real data science world. And so we saw many different programs and so on. So now it's all up to you, like how you practice these codes, and so you get a better grip over this. Now, in today's session, I'll be starting regarding the advanced version, that is a one step above that we have learned previously. So, where from the today's session, we'll be actually dealing with what different kinds of operations or the how we use the different advanced data structures to build or modify our data set so that we can infer some valuable insights. So essentially data science is all about like EDA, that is exploratory data analysis, like I always say. So you need to do certain kind of operation so that it gives you some meaningful result. So for that, I've basically decided to start with the very first type of library, in fact. So we have the very first basic library that is called as Pandas. So it will be in 2 to 3 sections that I'll covering this basic operations and different things that you should know in Pandas. So for this activity or for this task, we will be requiring a data set. So henceforth, whenever we do any kind of projects in the organization or in the real world, we will have to use certain kind of data sets. And so different data sets will also have different licenses, some of the copyright stuffs along associated with it. So for that, I have one data set. Now this data set is not a real one, but it is just for the demonstration purpose. So this is created by me. So in this you can see different data values. Like this is basically for the Ola rights in the year 2018. So this is just for the sole purpose of this video description. So you can find this code in my GitHub or this dataset, in fact. So you can do certain kind of operations. Now this is a dataset that we are going to use in order to do the data processing as well as to do any data visualization. So it consists of you can see, like you can have like from column and to, then you have the category, the source, destination, and the miles and the price in miles. And then you have some purpose like the customer visit or the person who are taking this cabs, what are their uh, visit, purpose of visit. So you have these many entries. So you have around 1156 number of entries in this. So for this, on basis of this, we'll be deriving some of the insights and some of the operations that basically you want to do when you get some certain file in Pandas. So we'll be covering few of the operations or basics in order to deal with this. So before that, you need to import this dataset. Now this dataset which I've shown, that is in spreadsheets that I've opened. So this is another product of Google, like spreadsheets, where you can open this similarly like to collaboratory. So you need to first put this dataset into this collaboratory, so in order to work with different operations. So you can see there are 3 items over here. So you have this show table of contents, and then you have some uh, like show code snippets pane, and then you have some files. So you need to click here on this file so you can see whatever data set you are going to import, it will be shown in this particular portion. So what you need to do is just right click this, and then you have to upload this. When you click upload, you can see like a pop-up will come, and you basically have to click over this, and just you can see what is the status of upload. So now it is uploaded. So you can see like in your collaborator you can have this CSV file. So it is a comma separated value. Also you can use the Excel file, whichever is given to you. So now we have just imported our dataset onto our collaboratory. Now first and foremost thing is like when you get this data set, you have to do certain kind of pre-processing. So if you know, or if you are well used to with the spreadsheet or Excel things, like if you know different kinds of operations on this, so first and foremost you need to check like if there are any date columns that are present. So if you have any date columns, just make sure that they are all in one format. Means, say for example, uh, so we can do some changes over here, so it does not affect our data set that we have imported in any way. So if you have say any data set, so now this data set is from the real world, so it can be like in any format. You can have this. So if you have any data value which is like this, so you can see that one of the value was like this. So you can see there are some discrepancies that are happening over here. So you can see that there are some values which are in hyphenated, and some values you can see that there are like there is a slash, that these two are the separators that are used for date. So make sure like you keep a uniform format of this dates. Otherwise there will be some kind of issues when you do the data processing on this. So for that you have to do certain preliminary steps before you input your dataset onto your collaboratory. So else you'll get some errors onto this. So having done all those things, let's begin. So first of all, pandas libraries are mainly used for the dataset handling. So whenever you want to do certain like indexing or slicing on different kinds of portions or columns or attributes, or if you want to have any restricted view or so on, you mainly use this pandas library. And there are different libraries where you can have, or you can do different visualizations, or you can do different kinds of other operations that are also possible. So, and this pandas is built on top of the NumPy, that is numerical Python. So that will be covering after some sections. So that is mainly used for like numerical operations. Like if you want to do matrix multiplication or stuffs like that, you mainly use that. So that is one operation. So there are n number of different things that are also possible with that. So if you see my other videos where I discuss the concept, so you can see like there are PCA stuffs and there are LDA stuffs. Then there are singular value decomposition and so on. So in these things, like when you want to implement, or when you see how this actually works, or what are the things that you need to do, you basically go with the NumPy. So that is mainly used for numerical calculations. So today we'll be seeing only just about the pandas. So first of all, we start with importing the libraries and the dataset. So for that we have this, that is we write import pandas as PD. So wherein other libraries we saw like from math import all, that is import star. So that was just for the math class. That is the basic library that is used. So that is not commonly used here, but we mainly play with the pandas, matplotlib, numpy, cbond, these kinds of libraries. So for that, first we have to import the pandas onto our workspace. So for that we write import pandas as pd, and if you see this pd is nothing but it is called as an alias, that is uh, alias. So it can be considered as a pet name. So instead of writing pandas everywhere, you write it as PD. So henceforth, wherever you access the object from pandas, it will be accessed via PD. So that is a small note like to write. So with every libraries you use, like if you have the NumPy, so import NumPy as NP, or if you have matplotlib, so import matplotlib as MLP or something like that. So somewhere you have to use the LIS. So LIS will help you like to wrap around one particular object so that it can be easily used for different operations. Next, once you do the LIS stuff, now with the LIS, you can access different methods that is there in the pandas library. So first of all, we write this, that is pd.readcsv. So that is an inbuilt method for reading the comma separated values. Similarly, you have something like pd dot now, yeah, you can see like there are different like rich kind of different operations that are available. So if I check for C, you can have read clipboard, read CSV, Excel, and Feather, HDF, HTML, JSON. Now like SQL, SPSS, SQL query, table, and many different kinds of things that are available. So that is the power of this Python library. Like you need not do any kind of other stuff, so you can directly use this inbuilt function from this library and you can use it. So how do you write that? So once you read the CSV, and then you have to mention the CSV file, so that we have this ola underscore writes underscore 2018.csv, and it should be a string. So inside that, so just like if you want to do it, just do the right click rename and then copy paste here, and you will get it, so that you don't make any errors while reading this. And now if I run this, what you get is you get all the table, just a small view of the table but not all. So you can see it starts from 0, then 1, 2, 3 and 4, and there are some entries in between, and then you get some like towards the last, and then you have 1 1 5 6 rows and columns. So that is nothing but this thing. So if you see, it is like this. And there is one more thing that I want to bring to your attention. Like if you see, that is this, now this is in spreadsheets. So you can see like the very first record that is here, it starts from 1. It is, you can see the ID or the indexing, basically it starts from 1. But when it is in pandas, it starts from 0. So the first that is record, so I call this as the record or the tuple. It is considered as the attribute. So after that, whatever entries are there, so that is our values. So you can see like that is a small difference that you have to keep in mind, and you can see this particular kind of table or your data set which you see here. Now let us do some of the basic operations on this. So for that, first, like we have these many columns and these many entries. So what I want to do is I want to know the different data types that are available in this particular data frame or from this particular CSV that I have imported. So for that, what I do is I write df.dtypes. So it will list all the particular attributes that are there. Now just mind you, like these things which you can see here, that is from, to, category, source, destination, miles, price per miles and purpose. So this, if I say what are these things, so that is, you will say that is nothing but the columns. Or some people will say those are the dimensions, or some will say those are the attributes. But in pandas, these are called as series, series, series. So this is one series, second series, third, fourth, and so on. So basically it will just list the data type of the series, and so by default everything will be stored as objects. So this, that is the from column, that you can make out like it will be in like date time format. It has a date and some time, so that is also an object. The to column, that is a to series, that is also in object. Category, which is the categorical, that is also in object. And the source, which is also in string format, that is also in object. A destination, that is also in object. And miles, which is there in some real value, that is decimal valued floating point, even that is also in object. But you can see that is the price per miles, those are in floating points. And so it will just distinguish among these two, like what are the objects and what are the floating points. So these are the two things that it will categorize into: one is object and one is float. The rest of the things you have to do certain kind of methods, or you have to do the data manipulation, so like it will transform from object to DateTime or something like that. So you have to do that kind of things. And also you can see there are some places like you have this NA, that is there here. So you can see NA. See, these columns are like NA. So NA means there was no data available. So that stands for not a number, or not applicable, not assigned, like that. So you cannot basically use that for data operations. So that will see how to get rid of that. So once you get the basic data types, you understand what are the different series or different attributes into this. You get the df.d types into this. Now what you do is you want to get a count, or you want to see the first few elements, what does it looks inside this. So for that you write df.head. Now if you write this, the default value that it will give is like 0 to 5. So you have 5 records: 1, 2, 3, 4, and 5. And if you want any more, so like if I write n is equal to 10, you can pass this parameter. So once it runs, you get like 0 to 9. So that is a total 10 count which you get, but since the indexing starts from 0, you get 0 to 9. So similarly, likewise, how much view you want to see from this particular Excel sheet, you can do that. Obviously, like you don't want to operate on the entire like list, whatever you see here. So that's why you can always open this spreadsheet, so that you get a idea of what you are basically doing. And similarly, from the beginning, if head shows you some data portions or some view from the beginning, so from the bottom how it looks like, for that you basically run df.tail. So from the base you get df.tail. And so if I write n is equal to 10 here, and if I run this, I get this particular thing. So why it ended from 1155? Because here it was from 1 to 1156, as I mentioned. So but here it will be different. So see, you have 1156, but here because it starts from 0, it will be 1155. So that's a small thing which you have to keep in mind, like when you deal with spreadsheet as well as the pandas. Now what I want to do is I want to see the description of all the data types that are there. So if you run that df.describe, it will see, like you can check the miles and price per miles. Whatever the real valued or the numeric column which you have in your data set, it will give the count, it will give you the mean, standard deviation, then minimum, then you have the 20th, 25th percentile, 50th percentile, 75th percentile, and the max value. So this basically serves like a standard for doing all the statistical computation. So you have some links with the statistics when you want to derive certain insights, or when you want to calculate some kind of other operations based upon this. So these are some kind of predefined stuffs that it is getting you by default, instead of doing any other computations or operations. So that is the main advantage of using the pandas library. Then there is one parameter inside this which you can pass, that is include is equal to you can write all, So if I run this, uh, you can see like earlier it was there only for the miles and price miles, that was for the numerical column. But there are other columns apart from that, like the start date or from, to, category and source. So it will give you the count and other stuffs which were not shown before. So it will give you all those things where this particular describe will be applicable. And so you can see many NaN values, that is not a number, not applicable, not assigned. So we'll see like how we can get rid of that. So that is one important thing when you do the data pre-processing or data handling. Next, what you have is you have something called as df.info. So it will basically give you the information of all these, like it can be said like a small summary of this particular data set. So you can first read that this particular class is pandas core frame data frame. So this is nothing but a data frame. That's why we write the df. Df stands for data frame. Then some range index, how many entries are there, and what are the numberings, that is 0 to 1155. Then how many data columns? You have 8 data columns, 3, 4, 5, 6, 7, 8. And so the number of each column, the column names, and the null non-null count. And then you have the data type, which are object and which are float 64. And the data types, so float 64, you have two, that is two entries, that is miles and price miles, and then objects you have rest of them. So it makes a total of 8 columns, and it gives you the memory usage, how many memory it is taking internally. So that is the basics of like the description of how much space it is taking. So whenever you want to do some kind of operations, it should be memory efficient or space efficient. So for that you will have this basic definition or like this operation. So but you don't use it more often, just for the summarizations you mainly use this. Now since I were talking about the NA values, so there is a lot of NA values which you can see here. So for that it has a predefined method, that is drop NA. So if you just run this, you can see like earlier there were many NaN values with this. So it will drop all the NaN values or NA values which were there, and now you can just put into some other variable, and then you can use for further basis for analysis. So that is the one important advantage that you get from pandas. Else the other way what you could have done is like you have to sit manually and you have to remove this NA values, do some filtering and stuffs with the Excel. So pandas gives you some inbuilt functionalities where you can use this to get rid of the NA values. Next, what I want to do is I want to count the start locations, unique start locations, where I want to do like a particular customer when he starts his journey from one source to one destination. I want to check what are the unique sources of that. Like I want to get the count of that. So if I run this, that is there is Krakow, Arnold Schweig, Morris Villa, White Bridge, Islamabad. So you get these particular counts. So now I'm interested in this particular count. So now this will be basis for certain analysis. Like it depends upon the statistician, like what kind of data he wants to get, or for what data he'll be using this, or what will be insights to lead some interestingness rules or measures. So basically for that, so I have also put a head here, so you can remove this, so it will give you the entire range. So that was just for the head. So head will give you some by default four numbers, or in that way four or five. But here you will get the entire like the source that was there, and you will get the count of basically that. Similarly for the uh, destination, so this should be destination. So with this also you get the same thing, and if I just remove this head, I get this way. So you have different destinations. Like moreover, it's same. Like it is also possible that the person does a round trip. So the starting location and ending location will be the same. So that is the basic thing about this. So you get like from how many what was his initial starting location, what was the later start location, and so on. So this kind of operations are also possible. Now, I'll talk about two types of indexing that is mostly seen or used in Python. So first is called as the positional indexing. So positional indexing is mainly done with the help of uh, operation, or in fact this is not a method, this is a operation, that is a built-in property. As you can see, that is the property object. So this you have already learned. So from the other data structures we have been discussing about the slicing thing. So it basically is the same. So ilog, I stands for the index and loc is for the location. So location based upon the indexing. So you need to give the indexing, like the position of each of the objects, what are there in that. And so you can see like it is separated by comma. So two entries are there. So the first thing which you can see on the left hand side, that is used for the row, that is for displaying the rows, and the second thing which you can see, that is for the columns. So if I run this, you can see first with the row you have 0 to 9, that is you get the 10 count, and then 0 to 5. So 0, 1, 2, 3, and 4. So you get similar kind of view, but for this there is one drawback, is like you, if you have too many rows or too many columns, then you need to remember like what, where or what are the index positions of these uh, series or the columns. So that is one major drawback with this. But with the current versions, or with the current techniques that the data experts use, the iloc is mostly deprecated, so they don't go with this. Instead they have something called as the label based indexing. So with that we mainly see. And if we do, so I'll just basically check if this is possible. So if I have, yeah. So what it basically did is, so just make sure like the uh, thing that what I did previously and what I did now. So first this will be for rows. So it will be 0 to 10, that is the 10 count, and this will be nothing but your uh, just show only the first zeroth column and the third column. So here if you see, uh, this was 0, 1, 2, and 3. So I want from and source. So 0 to 3, that is nothing but only 0 and only 3. If I want something before that, it will give you from and category 0, 1, and 2. So there is no slicing here. That is basically the view, restricted view that you want to do. So if you know about the data warehouse, you have this data cubes. So from data cubes you select particular section in order to display. So similar kind of thing is seen here, like slicing, dicing, pivoting, and things like that. So that you can same like do with this. So that is also a data warehouse kind of application which you can see. So that was about the positional indexing. Next we have opposed to this, we have something called as label based indexing. So labels are mostly like easier to remember than the numbers. So you can get to know like this is from, this is to, the category, source, destination, miles, and so on. So what you can possibly do is you can use the LOC function, that is just the location, and it will be based on the label. So that is why it is called as label based indexing. So you just write a colon, then you have the comma, and then you specify I want from and category. So if I run this, you will get the same thing. You get the same output, but it will be for all the rows, whatever is there. Just the from and category, what you have in this. So that is because I have not put anything before. So if I were to put this, so say like if I did like this, you get the same output uh, as opposed to here. So this is more commonly used than this iLock. So the major drawback is that you have to remember the positions, like which is the 0 one, which is the first one. So if you can directly get the names, that will be easy. So that's why we mainly go with the label based indexing. Next, I want to bring to your attention a small minor difference that this particular thing has. So when you access the data in this way, that is this is nothing but your label. So this can be considered as list of lists. So instead of writing loc, you can discard that loc and you can also write df of, and inside that you can pass a list from, so that I'm storing in X. So you get this kind of thing. So that is one particular column, and for that all entries. And if I want to use this, that is with lock, you get this kind of stuff. So like it is the same result, but it will give you in a some different format. So you can see that there is some kind of like a table that is seen here, but here you can't see any table. So there is a slight difference here. So I just want to uh, show you like what is this actually. So if I write type here, you can see pandas core series and series. And if I write this, that is type of X here, I can see those are frame and data frame. So when you get the data in this format, like in uh, this format, like you can see some highlighted or stuffs like this, you can see the cursor that is moving. So if you get this thing, that is nothing but your data frame. And what I previously shown, like it is like this, you get this thing. So that is just basic list, or like list of all the values. So that is a difference. Like when you deal with data sets, it will be a series, sometime it will be sometimes it will be a data frame. So that is the basic difference in this. Next, I want to bring to your attention like how you can convert object to datetime. So when you saw here, so when we did the operations like df.dtypes, you can see like from and to, those were objects, but you know those are not objects, but they are some uh, date time, or like in datetime format it is there. So is there any way like you can do that kind of internal conversion that is possible in this? So for that we have something called as pd dot to date time. So this is one function. It takes a data frame that is from, so something like this, df of this from. So then you have this format. So inside format, it takes one string of some particular format that is there. So you can see that is return value format, format specific defaults to the empty string. See the format specific mini language section for help formatting. So in the online Google Docs, which is there are different stuffs that you can do for converting these. So that's why initially in the beginning I said like you have to do this data pre-processing. So somewhere it will be hyphenated, somewhere it will be forward slash, so it can't handle both at the same time. So you have to keep in a uniform format so that it will work in one stretch. So for that you have to do certain pre-processing in your data set before you input into this collaboratory. So for that we have this format. Now just make sure like this format is in. So if I take this particular date, so that is nothing but, so if I go here better, so this will be first is my month, second 29 is my day. This will be my year, and there is some space, and there is this hour, and there is this minute. So in similar way, I have to write this, that is percentage m hyphenated percentage d hyphenated percentage y space hyphenated percent h, and then there is a colon hyphenated percent m. So if this was like with forward slash separated, so instead of this hyphenated you will put forward slash, so that is a basic difference. And so if I run this, what you can say is, now you can see this in a series format, but it will be converted internally. You can see like this is of, if I see here, that is this was object, now this is no more object, this will be a date time. Now the data type of this is DateTime. So you would like to put back this into the original uh, data frame, and then if you run, so you can see like the object type that was there earlier assigned to this would have changed to DateTime. And so I just want to mention about one particular parameter here, that is errors is equal to coerce, COERCE. So what if I remove this and if I run this? See, you get certain type of type error and value error, and if you see that is the day is out of range for month. So this kind of things happen because these kinds of data are from the user or from the company where you get this. So there sometimes it may be tab separated or comma separated. There will be some discrepancies while data entering, so that comes in data entry steps. So there will be some kind of ambiguities and some kind of misprints that is happening in this special character when it is transferred from one data file to other, or stuffs like that will happen. So if you don't want this kinds of errors, so for that we basically use this errors is equal to cover. So that is the universal fix to all of these things. So if you write this, you'll basically avoid those kind of day out of value error or key error or stuffs like that. So well, this was the small introduction. In fact, this was a long video. I thought to keep it short, but hope you got this basics about the pandas library, some of the methods and functionalities, and how we do the data extraction, like for selecting a particular view. So well, that was all regarding the pandas, that is section 1 in Python. So hope you guys enjoyed this video. If you want to got educated about this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.